Hello, sixth graders. Mr. LaBeouf here again, and these next few videos are going to be designed to assist you in doing some IXL problems from sixth grade math, section M, integers. And the first thing we're going to look at is a few sets of numbers. These squiggly brackets here are what mathematicians use to indicate a collection of numbers or a set of numbers. And the first set of numbers that we all, as very young people, learn is what are known as the natural numbers. That's why they're called natural, because they come naturally to us when we're very young. When we count things, if you look and see 4 apples on the table, the first number that we count with is 1. We don't count 0 when we're counting. The natural numbers are also known as the counting numbers. So they don't include 0, but it's 1, 2, 3, 4, 5, and so on. Now, if you add 0 to the natural numbers, include 0 as well, then you have what are known as the whole numbers. And these are the numbers that we operate with in the very early grades. We need the 0 when we're learning about arithmetic in the early grades, because 3 minus 3 is 0. And we also learn, of course, that when you add 0 to any number, you get the number. Once we get into middle school, we have to expand our understanding of what kinds of numbers there are. And it's not going to end in sixth grade. As you go forward, you're going to learn that there are even more and more different kinds of numbers. But just take it a day at a time, a week at a time, a year at a time, and then you'll be good with all of this. Now, here's a little bit of an unfortunate historical thing. I just Googled why are the integers represented with the letter Z by mathematicians. It's a stylized Z, just like the N up here was stylized. Now, this makes sense because the N here stands for the natural numbers. But this Z, my Googling of it just now told me that it comes from from a German word. Many of the words that we use are Latin or Greek in origin, but this is German in origin. Many of the great mathematicians in modern times, the 17th, 18th century, many of the great mathematicians were German, so perhaps that's why the German language was used. And it means something like whole number, although whole numbers and their opposites are really what the integers are all about. The integers are represented by the stylized Z by mathematicians. The integers are the whole numbers together with their opposites. Now, the opposite of 0 is 0. We're not going to list it twice. But here's how we can represent in set form what is this collection of numbers known as the integers. Now, the Z here that's kind of sophisticated. Not a whole lot of sixth graders will be introduced to the Z, but it's out there for sophisticated mathematicians in upper grades, so I thought I'd throw it at you. But this is absolutely essential. When I or anybody else mentions the word integer, you should understand what it means immediately. It's a very simple concept. Fractions are not integers. 2.5 is not an integer. Negative 2.5 is not an integer. Here's how we can represent the integers as a set of numbers. We can say dot, 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 because they go infinitely to the left. And let's start with, I might run out of room if I start with -5. So let me start with -3. -3 is an integer, but they go infinitely to the left. The next one to the left of -3 would be -4. And then further to the left would be -5, and so on. -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So as you can see, the integers are nothing more than the whole numbers together with their opposites. 0 is its own opposite. The opposite of 1 is -1. The opposite of 2 is -2, and so on. A very important vocabulary word and collection of numbers for middle school students, the integers. Now, if you look at this number line, it looks an awful lot like that collection of numbers that I just wrote for you, the set of numbers that are known as the integers. when you write it in the set form, if you just imagine these numbers being placed on a line and a point representing each one of them, and the points are the same distance apart from each other, of course, this is what you'd have. All right. So a line is infinitely long. It goes forever this way and that way. That's what the arrows mean. When we're looking at the integers, we typically put 0 in the middle. There's no such thing as the middle of a line because it's infinitely long. But the part we're looking at, we generally put the 0 there. And then we go a certain distance to the right and call it 1. We go another distance, the same distance to the right again and call it 2. We go the same distance again and call it 3, and so on. That distance, by the way, is called the unit distance. We can do the same thing to the left. We can go to the left of 0 by the same distance, to the left again by that same distance, by that unit distance, and so on. And when we do that, if we could do that infinitely to the right and infinitely to the left, and all of those points that we named would be the integers. Now, of course, there are points in between the integers that we call fractions, and also there are negative fractions. So let's talk a little bit about now the concept of distance from 0. Well, the number 3 is 3 units away from 0. But now there's another number that is also 3 units away from 0, whose distance from 0 is 3. And that, of course, is negative 3. Geometrically, we can say that 3 and negative 3 are reflections of each other across 0. When you reflect a point across 0, you go to the other side of 0 by the same distance. Negative 3 is a reflection of 3 across 0, and the other way around. 3 is a reflection of negative 3 across 0. It works the same way for the fractions. We know, of course, that there's a fraction 2.5. Fraction 2.5, or 5 halves, is 2.5 units to the right of 0. If you go 2.5 units to the left of 0, 1, 2.5, you will be at a point known as negative 2.5. The numbers that are the same distance away from 0, two different numbers that are the same distance away from 0, are known as opposites. 2 and negative 2 are opposites. 3 and negative 3 are opposites. 2.5 and negative 2.5 are opposites. 0 is its own opposite. When you add two opposites, you get 0. So let's get into the idea of adding integers. We'll start with this. 2 plus negative 2 is 0. You have a plus sign, and on either side you have numbers that are opposites of each other. Addition is commutative, so this could just as easily be written negative 2 plus 2, and it's 0. It works the same way with fractions. Negative 3.5 plus 3.5 is 0. We're going to see in the future why this is true, but I think it's pretty intuitive. Let me share this little bit, which is also from the future. When I wrote 2 plus negative 2 is 0, we're going to learn that that's equivalent to 2 minus 2. Adding negative 2 is the same as subtracting 2, subtracting positive 2. So you already know about 2 plus negative 2. You saw it this way, 2 minus 2. Now, in this area of once we introduce integers, there is a natural thing that we would want to do, and that is ask the question, how far is a certain number from 0? We don't really maybe talk about this that much in the lower grades because it's kind of obvious that the number 4 is 4 units away from 0. And even later on when fractions are introduced, it's kind of obvious that 3.5 is 3.5 units away from 0. But the numbers that are to the left of 0 have a certain distance away from 0 as well. And what I'm leading up to now is a concept from middle school math, and which will be valuable in many different areas going forward into high school math and beyond. And that is the concept of absolute value. The absolute value of a number is simply its distance from zero. That's all you have to know about absolute value, along with what the symbol is for it. Absolute value equals distance from zero. I think of this, in my mind, as I teach middle school students, I think of this definition of absolute value as in a very similar way to the definition of percent. Percent can sometimes be mystifying to students. You dealt last week with some percent problems, but if you always go back to the definition of percent, you can't go wrong, and it should be fairly easy. You know, X percent is X over 100, the definition. Everything about math flows out of definitions. You might view it as an onerous burden. We have to remember all these vocabulary words and definitions, but there really aren't that many of them. Compared to other subjects, there's a practically infinite number of factoids that you could learn from history or science. Math has a very limited number of these important definitions and concepts. Learn them well, however, and here's one of them. The absolute value of a number is simply its distance from zero. Now, I once heard, this is one of my favorite quotes about math. I'm not sure if it's attributable to one particular person, but it goes like this. Symbolism is to math what water is to swimming. That's an analogy, you know. We swim in water. We do math in symbols, with symbols. So you have to learn the symbolism. Two vertical lines with a number in between them. This is the symbol for absolute value. What this is asking us the question, what is the absolute value of 3? Well, 3 is 3 units from 0. The absolute value of 3 is 3. But here's the new consideration. Now that we've introduced numbers to the left of 0, we want to also be able to answer this question. This is asking us the question, what is the absolute value of -3? What is the distance from 0 of -3? Well, it's also 3, right? 3 and -3 are opposites. By the way, if two numbers are opposites, they have the same absolute value. That will always be true. There's no such thing as negative distance. Think about it. One thing being -3 feet from something else doesn't make any sense. Distance is always either positive or 0. If two things are right on top of each other, if 2 points on the number line are the same point, then the distance between them would be 0. So the absolute value of 0 is 0. How far away from 0 is 0? 0 units. This is all you need to know about absolute value, really. It's a very simple concept. The absolute value of a number is its distance from 0. And distance can never be negative. So if we want to be a little bit more sophisticated, instead of these 3 equations that I just erased, we could say this. For all real numbers are the numbers on the number line, including the integers and the fractions, and also other strange numbers known as irrational numbers, which you'll learn about later. For all real numbers, and we'll call the real number A. For all real numbers A, the absolute value of A is always greater than or equal to 0. This symbol here with the little line underneath means greater than or equal to. Why do we need the or equal to? Because of 0. The absolute value of 0 is 0. But the absolute value of any other number is positive, because no matter where the number is on the number line, its distance from 0 can only be positive. So we'll close it here. This is our very first introduction to the concept, the math topic of integers, and we'll pick it up next time. Bye-bye.